Greetings and welcome once again to my new calculus channel. My name is John Gabriel. So there's been a heated debate about the mean value theorem. And so one guy got on here onto my YouTube channel, some fool, whoever he is, and he's telling me that if I have f of x is equal to x cubed, okay, naturally f prime of x will equal to 3x squared. And I'm using the interval -1, 1, okay? So now he turns around and says to me that, yes, you can find a c, or in fact, you can find two c's in there, okay? So you have a c there and a c there, okay? This one here would be -1 over root 3, and this one here would be 1 over root 3. And the way to find that naturally is to say, take the what's happening here? Okay, take the difference at -1 and 1. So you'd say 1. Sorry, not. Let's just get rid of that. You'd say 1 cubed minus -1 cubed over 1 minus 1, which is 2 over 2, which is 1, right? So that would be the average value of all these ordinates here, okay? Of all these ordinates here. And yes, this area here, the red area, adds up to 2 square units, okay? And naturally, the arithmetic mean multiplied by the interval width, which is 2, is equal to 2, as expected. Now, so it was very easy for him to find this 1 over root 3 and 1 over 3 because you do it in high school. It's a simple problem. You just set this equal to 1, which is the value you got here, and then naturally that's plus or minus 1 over root 3. So there's nothing to that. But that wasn't the point I was making, okay? There's no problem there. There's no problem with that. However, there are many A, B intervals for C. What do I mean by that? Let's look. So if we come over here and we have a C here, right? There's not only one A-B interval. There are many. There are infinitely, as you say, many, okay? There are infinitely many. There's not just one, right? So if you move along here, wherever you move along, there will be many A-B intervals. So the interval itself is not such a big deal, except that the mean value theorem, this guy here, is correct. But is it correct when you have an inflection point? No, because that's the next thing I'm going to show you why it's not correct, okay? So what happens if C is an inflection point? It means what happens if you come along here and C is an inflection point here, like that. Okay, what happens now? What happens? So let's see what happens. There's not even a single AB that will satisfy this. There's not even one, by the way. There's not even one AB that will work if C is an inflection point, okay? And this is so because there is no tangent line at the point of inflection. And if there's no tangent line, there's also no derivative, okay? So the mean value theorem is therefore lying or being deceptive, or wrong actually is the better word, when it says what? When it says that if a function is continuous on this closed interval and differentiable, look here, and differentiable on the open interval. So it's saying to you that it's differentiable on the open interval, on this entire open interval here, on this entire open interval, not just at all the points except the point of inflection, because in mainstream, you believe in your idiocy that it's differentiable at the points of inflection, okay? So, therefore, when it says that there is a C in the interval, such that it's equal to the average rate of change of AB, it's garbage. It's not true, all right? And now finally, people, what I revealed to the human race is this, is a special relationship, by the way. And the mean value theorem is not about a parallel line like this that you see here. It's not about a parallel line Nobody cares about it's unremarkable that there are parallel lines to the sea. Totally unremarkable. What is remarkable is that, and I'm about to explain to you, is that the arithmetic mean of all these red lines under this curve here, under this blue curve, okay, under this blue curve here, the arithmetic mean of those is 1, okay? That's the arithmetic mean. And if we multiply it by the interval width, we get the area, okay? Now, if you say that F0 is 0, okay, then you'll have a problem when you try and find the area, okay? Because there is no AB. Let me use my pen. There is no f of a, f of b minus f of a over b minus a to give you f prime of 0 and equal to 0. There is none. Or I'm sorry, not equal to 0, but equal to 1, okay? Because you can't have this equal to 1 and also equal to 0. That's not possible, okay? 1 is not equal to 0. So I'm trying to explain this to you very neatly and carefully, but most of you are morons and you just don't get it. I don't understand what's so hard about this. You're all wrong in your understanding. Every single one of you. All those textbooks that you read are wrong. Now, I was the one who revealed to you that there's a special relationship. For example, when you have X and you have A and B, there's a special relationship here, okay, which is encoded in my new calculus derivative definition, which you all rejected in your idiocy. Okay, there's a special relationship. What this relationship says is that if this distance here is n and this or m rather, and this distance here is n, then this will be x minus m and this will be x plus n. Okay, and that's how you get this guy here. All right. It says there's a relationship between these distances and x. Okay, special relationship. So to learn more about that, you'd have to study the new calculus. Now, there is no derivative at the point of inflection. That's why the mean value theorem is lying. Okay, let's go back there one more time. There's no derivative at the point of inflection. So the mean value theorem states that if a function f is continuous on this closed interval and differentiable, okay, that means it's differentiable at every point, not just at the points you choose. It includes the inflection points, okay? And if it's differentiable at the inflection point, then it says, then there exists a point C in the interval. It's differentiable at C, such that f prime of C is equal to the function's average rate of change of AB. And remember, it doesn't matter which AB it is, okay? There is no such AB for an inflection point. If you're not a rare subscriber, please become one. Follow me on academia.edu. Click like, because your mainstream math professors and teachers and their lackeys are all idiots. Do you want to be like them? I'm John Gabriel. Till next time.